Mars, the red planet, has always captivated our imagination. It's a world of stark beauty, with rusty red dust and towering volcanoes. But one thing that sets Mars apart from Earth is its atmosphere, or rather, the lack of it. Mars has a very thin atmosphere, about 100 times thinner than Earth's. The Martian atmosphere is mostly carbon dioxide. This is a greenhouse gas, which means it traps heat. However, there's just not enough of it on Mars to make a big difference. The thin atmosphere also means that Mars doesn't have the same protection from the sun's radiation that we enjoy on Earth. This makes it a very harsh environment for life as we know it. Exploring Mars's atmosphere is crucial for understanding the planet's past and future potential for life. By studying its composition and dynamics, we can unravel the mysteries of this alien world. Because Mars's atmosphere is so thin, it can't hold on to heat very well. This means that temperatures on Mars are much colder than on Earth. The average temperature on Mars is about -80 degrees Fahrenheit, or -62 degrees Celsius. However, temperatures can vary wildly depending on the time of day and the location. During the day, temperatures at the equator can reach a balmy 70 degrees Fahrenheit, or 21 degrees Celsius. But at night, they plummet back down to -100 degrees Fahrenheit, or -73 degrees Celsius, or even colder. These extreme temperature swings are due in part to the Martian atmosphere's inability to retain heat. Without a thick blanket of air to insulate it, the surface of Mars heats up quickly during the day and cools down just as quickly at night. Understanding the temperature variations on Mars is essential for planning future missions, and potentially even for establishing human settlements on the red planet one day. Even though Mars is a cold, dry desert today, there's plenty of evidence that it was once a much warmer and wetter place. Scientists have found evidence of ancient rivers, lakes, and even oceans on Mars. One of the most compelling pieces of evidence is the presence of water ice at the Martian poles. This ice is thought to be the remnants of a much larger ice cap that once covered much of the planet. Scientists have also found minerals on Mars that can only form in the presence of liquid water. These minerals are like fingerprints, telling us that water once flowed freely on the Martian surface. The evidence for past water on Mars is one of the most exciting discoveries in planetary science. It suggests that Mars may have once been habitable, and it raises the tantalizing possibility that life may have existed there. So what happened to Mars? How did it go from being a potentially habitable world to the cold, dry desert we see today? Scientists believe that Mars's climate has changed dramatically over billions of years. One theory is that Mars lost its magnetic field early in its history. The magnetic field protects a planet's atmosphere from being stripped away by the solar wind, a stream of charged particles from the sun. Without a magnetic field, Mars's atmosphere would have been slowly stripped away over time. As Mars's atmosphere thinned, the pressure at the surface decreased. This would have caused any liquid water on the surface to evaporate or freeze. Over time, Mars lost most of its water and became the dry, dusty planet we see today. Understanding how Mars's climate changed in the past can help us predict how the climates of other planets, including our own, might change in the future. By learning from Mars, we can better protect our own planet and ensure a sustainable future for all.